Hi, this is Margo. This is May 31st, 2018, and I have a really special show today and a very special guest today. I have Guy McPherson on the line, and the title of the show is Methane Unveiled and Q&A with Guy McPherson on Abrupt Climate Change. Now, I interviewed Guy a little over a year ago, and we had a really interesting discussion about abrupt climate change and near-term human extinction and different things. And that show really kind of changed my life, and I'm really glad to have Guy back with us today. This is a live conference call-in show, and for whoever calls in and wants to ask questions, Guy is live on the line today. So Guy, why don't you go ahead and introduce yourself, and then we'll get going.
Thank you, Margo. I'm Guy McPherson. I'm Professor Emeritus of Conservation Biology at the University of Arizona. I now live in Belize, and for reasons quite unclear to me, and strictly non-intentionally, I have somehow become the world's leading authority on the topic of abrupt climate change leading to near-term human extinction. So I think that's enough to get us started.
Well, yeah, and a lot of people have already know about you and follow you, and I followed you for probably about a year and a half now, and like I was saying, that interview with you really changed my life, and it put a lot of things into perspective, and I started losing clients after that interview because they didn't want to hear about, our time is short, and and I even tried to get on some other radio shows as a guest, and when they saw that I had read one of your blog posts and put it up on my YouTube channel and that I'd interviewed you, they said they didn't want that kind of energy. They didn't want their audience exposed to that. So, isn't that crazy?
Wow.
Yeah, and I've come under attack, not as much attack as you do, but I can appreciate what you're doing, and you just have to have a lot of courage and just keep moving forward to get this word out and this message out, because I feel like it is the truth and the time is short. So I appreciate you doing what you're doing. Now, the purpose for this show, originally I found the CAMS website. That's the Copernicus Atmosphere Monitoring Services website. I found that recently and have started exploring it and have been looking at methane levels, carbon dioxide levels, sulfur dioxide levels, and I started doing a series of videos and putting them up on my YouTube channel, just showing like what I found on this CAMS website, and they've really taken off, and I've had lots of comments and lots of questions and things, and so I thought I would bring you on and we could talk about some of my questions and the questions I've gathered from people about methane and also some of these other greenhouse gases, and I've got other questions too. So you're up for that, right?
Absolutely.
So you're familiar with the CAMS website, right? I would assume so.
Yes, of course.
How reliable do you think that the information is that we're seeing there?
Well, I think that they are just taking information from reliable sources and promulgating it, just forwarding it on. So I think I've seen nothing to indicate that they're an unreliable source. As nearly as I can tell, they are presenting accurate information. So I think it's good. And it's one of many sources, and people can check in other places. NASA, for example, and the European Union has a website I can't recall offhand. So it's not as if there's only one place to track down the level of atmospheric greenhouse gases. So, it's always good to double check, but I haven't seen anything to suggest that the Copernicus website is anything less than reliable.
Okay, well, thanks for that. I'm kind of like honing in on it because there's so much there, and it's I'm learning it, and I learn more every time I look at it and every time I do stuff. Now, on the readings, you can measure these greenhouse gases from like surface level to total column and everything in between from 50 HPA to 850 HPA. What's the difference between those different levels, and how would you recommend we go about reading these?
Well, the different levels in the what they're showing there is different levels in the atmosphere, and beginning with flat measurements that actually capture the greenhouse gas concentrations in a flask at or near surface level. So that's where the collection starts. And then at various levels in the atmosphere, the reports are reported according to satellite data. And, you just have to make sure that you're comparing apples to apples over time, for example. So the level of methane in the atmosphere at the beginning of the Industrial Revolution, about 1750, was around 750 parts per billion. That's for methane. Carbon dioxide was about 280 parts per million with an M. And now we have slightly more than 410 parts per million carbon dioxide in the atmosphere. And the methane readings are considerably more variable from source to source and from moment to moment. Earlier this week, there was a spike up to more than 3,000 parts per billion of methane in the atmosphere. That's billion with a B. So that's 4 times the level that was present at the beginning of the Industrial Revolution. But that was a spike over the Arctic Ocean. There's more variability with methane than there's with carbon dioxide in the atmosphere with respect to measurements. And there's also more variability with respect to readings over space as well as over time. So I think we can easily, conservatively conclude that the methane in the atmosphere is more than 1,800 and likely more than 2,000 parts per billion on an ongoing basis. But it isn't like it is with carbon dioxide in the atmosphere, where once it reaches 410 parts per million, it is only going to go down slightly when the spring and summer in the northern hemisphere are taking the carbon dioxide out of the atmosphere as a result of photosynthesis. And it's going to be only a slight decline. So the variation throughout the year is on the order of 1 to 4 parts per million CO2 in the atmosphere, and the variation in methane is considerably higher than that. From one reading to another, from one day to the next, it might be 1,000 parts per billion or 1 part per million variation. But because methane is occurs at relatively low concentration in the atmosphere compared to carbon dioxide, it is also more variable in the atmosphere.
Okay, thank you for that explanation. I'll get started with my questions here. Now, sometimes, you can look at the methane on the CAMS charts and things, and it looks like it's trailing in the atmosphere, and sometimes it just like pops up instantly. Is there much trailing that goes on with the methane?
What do you mean about?
Like it'll look like a cloud of it, like it starts moving like smoke or something, like through the atmosphere. Would that be the trailing, or is it really coming up again there?
I don't know. I don't know enough about the interpretation of the readings.
Oh, okay.
This is like a radiologist reading X-rays or me
Right.
reading X-rays.
Right.
And the radiologist knows more than I do, and so do
Right.
the people who work with methane every day.
Right. Okay. Okay. Here are some questions that I've gathered. If enough methane is released into the atmosphere, could it cause the atmosphere to catch on fire, say, with a lightning strike?
That would be very unlikely. We need about 5% or 5 parts per 100 methane in the atmosphere for it to be flammable. And that's a very, very high concentration of methane. Now, could it happen? Yes, it could happen. But I would consider it extremely unlikely. You know, that's getting up there in the same order of magnitude as oxygen in the atmosphere, for example, and methane doesn't come close to that, at least so far. We're talking parts per billion, and we would need parts per 100 to make it flammable.
Oh,
so
okay.
It's unlikely, but
okay.
There can be accumulations of methane due to atmospheric phenomena that I don't fully understand. So is it possible? Sure. Is it something I would worry about if I'm taking a walk in the woods? No, not at all.
Oh, okay. Okay, thanks. Here's another question. Could higher methane levels cause more severe and out-of-control wildfires?
Yes, I don't think there's any question about that, and primarily not directly, but because of the rapid heating associated with methane. Carbon dioxide, the maximum heating associated with carbon dioxide release is 10 years after the carbon dioxide molecules are released. With methane, it's instantaneous. So maximum heating associated with methane release occurs upon release of the methane. So if, for example, you have a wildfire burning in what used to be permafrost or burning around bogs, and there's considerable methane there, initially stored below ground and then upon release, there's little question that there can be what I would consider a minor direct effect, and then more importantly an indirect effect as the heating is increased, first locally, then regionally, then globally with respect to methane. So, if there is a wildfire burning in an area with methane concentrations, then yes, absolutely, that will increase the heating and perhaps also contribute to fuel for the fire. I don't know if you've seen any of the pictures of Hawaii lately as the lava is flowing out of the Big Island. And there's a lot of pictures being taken of the fires there, and they're all burning blue. That's because they're burning methane.
Right. I did a show about sulfur dioxide and did some research on volcanic gases that are released from volcanoes, and found that methane is one of the gases that's released. Carbon dioxide, sulfur dioxide, methane, and then a whole bunch of others. So, people don't realize that.
Methane that directly influences those fires in Hawaii right now.
Oh, wow.
But I would think that would be pretty uncommon, because for the most part we don't have forest fires or even wildfires burning in areas with very high methane concentrations.
Right. Yeah, because normally it's got to be more humid for a lot of methane to be coming up, where you've got the decomposing matter and things like that, right?
Yes.
Yeah.
Yes, absolutely. So if you do have forest fires, wildfires around bogs, for example, where that methane is much more common, or burning in permafrost, there's lots of areas of permafrost. I'm sure many of our viewers have seen the videos on YouTube of former permafrost that is just slumping down a hill, just sliding down a hill, mostly in Siberia. And so those areas have become dry enough. The grass in the areas has become dry and burned, and the methane concentrations coming off of that rapidly decomposing permafrost must be very, very high, both methane and the carbon dioxide.
Right. Okay, here's another question. How many parts per million, he says parts per million, he probably meant parts per billion, of methane is toxic? That was the question.
Yeah, I don't have the slightest idea. Like, can you go out there and breathe it and survive at what concentration? It's pretty clear that, for example, when a couple or 3 years ago, NASA was reporting methane bubbling out of the Arctic Ocean in areas up to 150 kilometers across. And I know that you could not be in a watercraft, in a boat or a ship, and go through that area and survive because the methane concentration would be too high. But I don't know what the Rubicon is. I don't know at what level atmospheric methane becomes essentially poisonous or replaces the oxygen to such a high level that it becomes toxic.
Okay. But that's kind of a moot point because, we've got so many toxic things in the air and the greenhouse gas is building up. And it's definitely affecting our health and affecting all of the living planet because if you can't get as much oxygen as you need, then your tissues aren't going to form right. You're going to have brain fog. You can't think as well. I mean, it's a whole thing.
Right, and in some areas of the globe, particularly in cities, we're already seeing that play out. So you get down below 20% oxygen concentration in the atmosphere, and it becomes difficult, or at least it disrupts cognitive function when you breathe that oxygen at such a low level. And almost no place around the planet now can you find 23% oxygen in the atmosphere, which is what we had when I came onto this planet in 1960.
Yeah.
So that's rather unsettling all by itself.
Yeah, agreed. Okay, here's another...
I'm a big fan of breathing, and I think most people are as well.
Yeah, we kind of need it. Okay, here's another question. Guy McPherson said in one video that there's 5 gigatons of methane in the atmosphere. That was a while ago. Do you know what we're up to now? I think that...
No, again, because it's so variable from one day to the next and one location to the next, I think. And I haven't seen anybody who specializes in the topic collating the information from place to place around the globe and coming up with a reasonable number. So I suspect it's more than 5 gigatons, but I don't know any more than that.
Okay. All right. Let's talk a little bit more about Hawaii. Do you feel that Hawaii's volcanic activity is related to abrupt climate change?
Yes, I don't think there's much doubt about it. And here's the connection. As the ice melts, and certainly the ice is melting all over the globe, the number and size of glaciers is profoundly reduced compared to 10, 15, 20 years ago. As the ice melts, it takes a lot of weight, a lot of mass off of some of the continental plates. So Hawaii is right there at the Ring of Fire at the intersection between the Pacific plate and whatever plate or plates lie to the west and south of Hawaii. I don't know what those are. And the Ring of Fire around the Pacific plate is exhibiting all kinds of activity that is unprecedented. And so the volcanism we're observing in Hawaii is undoubtedly a result of the differential change in mass of the material on the various continental plates. And, you don't have to look very far to see volcanism on the increase, earthquake activity on the increase, and these are almost certainly related to ongoing abrupt climate change as a result of changes in mass due to glacial melting. So it's not just Hawaii, it's New Zealand, it's Iceland, it's places that have been characterized by volcanic activity in the past, and now we're seeing an acceleration of that kind of activity.
Right. Right. That makes sense. Okay. Here's another. This was one of my questions. I was looking at the CAM's website, and on May, I think it was the 25th, um, all these bursts of sulfur dioxide just like appeared suddenly, and there was one from Hawaii, of course, where the volcanic activity is going on. There was one in Brazil, and there was one that popped up in northern Siberia, and they all popped up right at the same time. Really like high level of sulfur dioxide. And I was just wondering, what could be releasing that sulfur dioxide from Brazil and North Siberia like that?
That's a great question, Margo. And when a professor says that's a great question, it's because he doesn't have the slightest idea what the answer is.
Well, I have my theories, and I'm thinking that there might be, earthquakes and volcanic activity going on, and it's also like up in northern Siberia, there's very high methane release in the same area as well as where the sulfur dioxide was. So I'm thinking there's something going on there, and it's being released from the ground. And when you,
I've no doubt about that. I've no doubt that there is increased volcanism and continental plates shifting around, and that coincides with the last place we would want that to happen. Places like Siberia, which are just completely loaded up with methane and sulfur dioxide.
Right.
Carbon dioxide. And the permafrost, when it starts leaking out pressurized carbon dioxide and methane, as it has been doing, that is a cause for serious concern, to say the least. So I have little doubt that there are connections between volcanism, continental plate movement, climate change, and I haven't seen, probably because I haven't been looking, the connection to sulfur dioxide recorded anywhere.
No,
so
nobody's looking
at it. The three observations you're seeing from around the globe may well indicate a pattern or a suggestion of potential increase in the future, but I haven't seen anybody write that up anywhere.
Yeah, well, I'm just looking at the pictures and saying, boy, that looks interesting. And they're popping up all at the same time, in these different parts of the globe. And then you move the movie forward, and then the red cloud moves up from northern Siberia up to the Arctic, but then instead of really dissipating, it's like red again in the Arctic. So it implies to me that there's sulfur dioxide coming up through the cracks in the ice or something. I don't know.
Yeah, I just have one piece of advice for you about that, Margo. Just stop looking.
And then I started, I like to go down rabbit holes, and so I started looking at for articles for undersea volcanoes in the Arctic, and I only found like 2. And there's lots of stuff about the Antarctic, and then the 2 that I found about the Arctic were very old, and there were, in one of the articles they said that the scientists thought that the machine that they were measuring the sulfur dioxide coming out from the ocean was wrong because it was so high. But they checked it, and the machine was right. And that was from like 2003 or something. And there's nothing out there. So.
Right. I suspect that the world's leading authority on sulfur dioxide and a potential Canfield Ocean event is a guy named Peter Ward.
Okay.
And Peter Ward is a scientist formerly at the University of Washington, or maybe he's still there. I heard a rumor that he was living in Australia now. But he wrote a book called Under a Green Sky that describes what happens when we get into, or he surmises what has happened in the past. He's a paleoclimatologist.
Okay.
So he's surmising in that book what has happened in the past when we have the Canfield Ocean event, that too much sulfur dioxide is spewing into the ocean and causing what he calls a green sky, at least on the horizon. So you might want to contact him.
Okay.
I think he's probably the person, the go-to person for that information.
Okay, great. Thanks for that. Okay, here's the next question. Someone wants to know what's going on with the ozone layer.
Oh, yeah. It's another disturbing situation, to say the least. It's one of the self-reinforcing feedback loops that we've known about for quite a while. As the planet heats, the ozone in the atmosphere gets stripped away, and as the ozone in the atmosphere gets stripped away, we lose that protective layer, that umbrella from the O3. That's what ozone is. And so it gets hotter. The hotter it gets, the more ozone we lose. The more ozone we lose, the hotter it gets. And, you know, the atmospheric ozone was brought to our attention during the Reagan administration, a little bit before that maybe, when the, quote, ozone hole over Antarctica was discovered and it was growing in size. And so we made some relatively significant changes in the infrastructure and the way we live. We basically phased out fluorocarbons in lots of places, and that caused, with about a 30 or 40-year lag, it caused the hole in the ozone layer over Antarctica to stop growing. So people think that means we solved the problem, but in fact all it did was stop the so-called hole from growing anymore. Well, now we have ozone holes, or thin layers of ozone, popping up all over the planet. People tell me on a pretty regular basis, especially gardeners or foresters, people who work outside on a regular basis, that the sun feels hotter on their skin than it ever has before. It actually feels hotter to them, physically hotter than it ever has before. And the only reasonable explanation I can come up with for that is this depleting ozone and the thinning of the ozone. And of course, it's in the atmosphere, and it's all swirling around, and it's all interconnected throughout the globe. So it might be hotter in Belize, for example, where I live, for 3 or 4 days in a row, and then it doesn't seem that the sun is hotter than it used to be. And so these things sort of pop up and move around. But if you're outside on a regular basis and you're paying attention, you're starting to see that on an increasing basis. So this is yet another outcome of abrupt climate change that is evident to people who are working outside. It's evident to people who are gardening, for example. And it's not the only thing. You know, there's all kinds of biological and ecological conditions that are evident to people who are working outside. This is just one of several.
Right, that makes sense. And, you know, I know that when I'm outside, I just heat up so much faster than before, or driving in my car, I feel like I'm just going to explode, even with the air conditioner on. So I could attest to feeling hotter. Do you...
I attribute that myself to old age and impatience, but there's probably something physical to it as well.
Yeah, I think it's a whole combo plate.
Right.
Okay. I don't know if you'll go into this question, but here we go. Are the microwaves emitted from cell phone towers contributing to heating of the atmosphere, do you think?
That's another fun question, Margo. And you know what that means. I have no understanding of that situation at all,
okay.
So I won't even comment.
Okay. Well, we'll move on. Okay. This is...
As it turns out, there's quite a few things I don't know, and I suspect you're going to expose them all before we're done here.
Oh, you're funny. Well, you know, I appreciate your honesty. You know, a lot of people would just kind of BS their way through, but I appreciate your honesty. Okay.
You know, when I was teaching college classes, I would never do that.
Right.
And certainly would never do it today, where anybody can fact check my answer in 20 seconds on their smartphone.
Right. And
so it doesn't make any sense if you don't know to
right.
just make stuff up.
Right. And, you know, we're in the classroom here, and we're all trying to learn and understand. So Okay, and you answered this question on my YouTube channel from this guy that asked it 3 weeks ago, but it was a really good question. If you'd like to elaborate on your answer, you can. So I will read it. It's kind of long, but here we go. This guy says, what I want is a scientist to explain to me what happens to the methane when it interacts with the atmosphere and creates water vapor and carbon dioxide. So methane interacts with oxygen in the atmosphere and forms water vapor and CO2, which are both in themselves potent greenhouse gases. So is it true that once that the methane breaks down, it remains for decades and centuries in the atmosphere as CO2? They tell us that methane is 86% to 100% more potent as a greenhouse gas until it's broken down into water vapor and CO2. So what I'm understanding is that we have this very potent GHG in methane that is very time limited, 20 years, which then degrades to CO2, which can last for a century or for centuries. So methane is far more dangerous than CO2, it would seem to me, because it has a quick kick and then a long, slow follow-through. And the expectation is that just in the ESAS, or the Eastern Siberian Ice Shelf, there is enough methane close to the sea surface for something like a 50 gigaton quick release over a short period of time. I understand that actual research has been carried out by Natalia Shakova et al. Over decades that shows that increasing amounts of methane are being released from the ESAS. Her work has been backed up by researchers from the University of Alaska, Peter Wadhams, and researchers from Scandinavia. As her research has gone on, more researchers come on board with corroborating evidence/research. As more of the Arctic becomes ice-free, more methane is expected to be vulnerable to quicker release. Sounds like an accelerating positive feedback mechanism to me. So there you go.
I answered that?
Yeah, you said bingo. You said bingo.
Well,
I emailed you that question, and you responded. You commented on that under the comments on the video, and you said bingo.
Apparently, I can't keep track of everything I do.
Oh well.
3 weeks ago, but I think that's a wonderful description, actually.
I thought it was really detailed and good the way you outlined it.
Absolutely, and this is what happens. CH4 is released, and some people think because CH4 or methane breaks down relatively quickly, decomposes relatively quickly, that it's not that big of a problem. But there's two issues I have with that. First of all, when it breaks down, it decomposes, as this individual pointed out so clearly, into water vapor, which is a very potent greenhouse gas with an equilibrium time of days with global average temperature. And it also breaks down into CO2, carbon dioxide, which the impacts of which persist for at least 1,000 years in the atmosphere. So the first bit of bad news is that methane breaks down into these two other greenhouse gases. The other bit of bad news that almost nobody ever talks about is that while the individual methane particles are breaking down into carbon dioxide and water vapor, there's a bunch more on the way. So it's not as if we have solved the problem by having all of last year's CH4 decompose into water vapor and carbon dioxide. On the contrary, we have more CH4, more methane this year than we did last year. So we haven't really solved anything. We've just created two more potent greenhouse gases out of what was an incredibly potent greenhouse gas to start with. So it's as if we're doubling down on the greenhouse effect when we release methane, and it's not going away when it decomposes into water vapor and carbon dioxide, and there's a bunch more on the way besides. So the level of methane in the atmosphere continues to increase, at an exponential rate. And even though it's breaking down, and even though it breaks down relatively quickly into these other greenhouse gases, that doesn't solve anything. So the situation gets worse, and then it gets worse. And then the closer we look, the worse it looks.
Right.
So this description, this detailed description, was actually very well done, and left me with little to say. So you get me on the air, then I have seemingly everything to say.
Okay.
One of the reasons that I give cryptic answers, very short answers online, is that 99.9% of my work is done on a phone, and so I'm tapping out on a keyboard that's approximately the size of my thumb. And the other reason is that where I live in Belize, we have the second worst telecommunications infrastructure in the Caribbean region after only Cuba, and also the most expensive. So
wow.
The internet bill is exorbitant, and every letter I type costs a little bit more. So that's why I try to be relatively brief in my responses, and the fact that I get still 200 or 300 email messages today, along with those YouTube comments and other social media.
Wow. So that's why you try to do what you can when you're in the States to help out with that.
Yes, that's why we're having this conversation
Okay.
when I'm in the States. When I get to a, quote, first world country with decent telecommunications infrastructure, I try to take advantage. And so on this trip, I think I lined up 4 interviews. Just because I just can't do this when I'm in Belize. It's outrageously expensive, and the infrastructure is just too poor for a real-time conversation.
Yeah. Okay, here's the next one. This lady wants to know about the Antarctic. She says, I've heard that the eastern side is gaining ice and losing it on the western side. Could he explain why this is happening? Also, I was surprised to see that Australia didn't have a lot of methane release. Would that be because it is autumn in the southern hemisphere? I noticed that the methane shading appeared to be mainly in Queensland. Would this be due to fracking or open-cut mines? So that's the question.
Yeah, I don't know what. There's a whole bunch of questions, actually.
Yeah.
And I don't know the source of the methane in Australia. As we are, we have opposite seasons. So spring here is autumn down under.
Right.
So that certainly is a reasonable explanation. Also, we have to keep in mind that aerial extent, what is frequently called extent of ice, has, in many cases, little to do with the volume of ice. So if we're losing ice extent in the East Antarctic and gaining it in the West Antarctic, that might be because it's the fresh water that freezes quickly and is maybe a half an inch or an inch or 2 inches thick on the west side, and freshwater, non-salty water freezes at a higher temperature than saltwater does. So it could be that there's just a bunch of melting of surface ice that's going out and lying on top of the salt water and freezing in a very thin layer of ice. So that's one of the reasons that aerial extent is a pretty poor measure of ice quantity. Volume is a much better indicator. I'm not sure what's being measured here, but it sounds like that might be part of what's going on. So as it warms in Antarctica, as when it warms in the Arctic, at least in some locations, the ice that melts, whether it's surface ice, terrestrial ice in the case of Antarctica, or even some places where there are glaciers in the Arctic, or whether it's floating ice, that fresh water melts at a higher temperature than salt water does and forms a confusing layer of thin ice on the surface of the salt water. And it's confusing because when you look at it from above, it's just reflective ice. If you're just looking at cover at aerial extent, it's misleading in terms of the volume or the real capacity for that ice to take on additional heat.
Right, right. Well, that makes sense. I have some more questions, but we've got a couple of callers, and let's see if one of those has a question. Anyone who's called in, if you have a question for Guy, if you'll push *5 on your phone keypad and raise your hand, we can get your questions answered. Anyone have a question?
I see a hand up there at the back of the room.
No, not yet. I mean, I can go around the room and ask. Why don't I do that? Okay, here we go. Hi, Barbara. I talked to you earlier.
Hi, how are you?
Oh, good.
I have a question.
Okay.
Hi.
Hi.
I'm back again.
Okay, yeah, we got you live.
Is the methane increase breakdown have anything to do with the increase of wet bulb? The wet bulb temperature?
Yeah, I think I understand the question. Lethal wet bulb temperature, that is the temperature, the combination of temperature and humidity, which is lethal to human beings, is 95 degrees Fahrenheit and 100% relative humidity, or increase in temperature and decreased in relative humidity. That is unrelated, as far as I know, to methane release, except that as it gets hotter in any particular place, of course it's going to be more prone to methane release in that particular place. But for the most part, the places that we are seeing lethal wet bulb conditions develop are near the tropics. And for the most part, again, there are exceptions, but for the most part, worldwide, that is not where the methane has been being released in large quantities. So places like where I live, Belize, India, Bangladesh, these are places that we hear about people suffering as a result of high levels of heat and humidity. And those are not the places we are hearing about large methane releases. So I don't think that there's a correlation, except if you look at the scale of the whole globe. As it heats up, methane obviously is more likely to increase, and also the incidence of lethal wet bulb temperatures is increasing as well.
Okay, thank you, Barbara, for your question. 707, do you have a question for Guy?
Hi, can you hear me?
Yes.
Yes.
Yeah, I haven't heard much mention about fires. This is Gaio, and the fires cause the sulfur dioxide, and these huge fires in Siberia not only might be releasing a lot of sulfur dioxide, but that loss of biomass is kind of like the loss of ice. I mean, that could be causing some tectonic rebound, as well as the amount of moisture, like these 1,000-year floods now, that like the one in Houston that they thought might have caused the earthquake in Mexico because of the amount of water that was dumped in that short amount of time. That was just a couple of input things I had. Go ahead.
Yeah, Gaio, you're right. And thanks for calling in. Haven't seen you for a while, my friend. And
yeah, good to hear you.
All of these things are related. And everywhere you look, everything is getting worse. So there's fires burning in Mexico. There's, as you mentioned, a 1,000-year flood event in Houston. I heard about 2 1,000-year rainfall events within a 2-day period of time outside of Baltimore, Maryland. 2 1,000-year rainfall events in a couple of days. That's not supposed to happen. And it's all happening, and it's all happening faster than expected by almost everybody. And no matter where you look around the planet, there's evidence of abrupt climate change, whether it's in the form of fires or the shifting continental plates contributing to volcanic activity or the rapid melting of the glaciers. The list just goes on and on. The rain bomb, the term that we never heard until about 5 years ago, and now everybody knows what a rain bomb is. Most people have been hit with one. So, and just recently we have the phrase, the Dust Bowl that never ends, referring to the southwestern United States all the way up into Canada, where the drought is already severe. So it's like George Carlin said years ago, everything's going to get worse. Nothing's going to get any better. Don't even think that the future holds much joy for very many people, because it's all going to the proverbial hail in a handbasket, and it's all getting there much more rapidly than most people expected. So anybody who's willing to accept the notion of abrupt climate change is able, almost on a daily basis, to link some phenomena together from around the globe that are contributing to and resulting from, sometimes both, abrupt climate change. And you're mentioning the fires, the loss of biomass and sulfur dioxide and carbon release into the atmosphere from those fires. Your mention of the rain bomb in or near Houston. You mentioned the glacial loss and the shifting of the continental plate, and the resulting volcanic activity. All of these things, it just takes a large view. If you're willing to look from place to place around the planet, horrific things are happening. It reminds me of the bumper sticker I saw probably 25 years ago. Where am I going, and why am I in this handbasket?
Right. Well, thank you, Gaio, for calling in and commenting. We appreciate you being here. Okay, I have another question. Could you ask Guy why the big difference between the northern and southern hemispheres regarding carbon and methane emissions? I mean, I was showing that in my video, how there's almost a line where it's just above the equator, where it goes from blue to green almost immediately. And anyway, she goes on and says, can't remember if I asked you to ask Guy about the methane emissions in Australia. As we don't have melting permafrost, would they be coming from fracking? So that's a couple of questions there. So
ultimately, looking at the big picture, again, this difference between the northern and southern hemispheres is a result of there being essentially all the land on the planet concentrated in the northern hemisphere. And the ocean, the water, has a certain specific heat and certain lack of land use practices that make the ocean very different from terrestrial areas. So, for example, the interior of large continents heats up at least twice as fast as the global average. So if you have a lot of land in an area like we do in the northern hemisphere, then that's going to be reflected in higher temperatures, which is going to be reflected in more rapid carbon dioxide release as plants respire more rapid methane release, and so on. And the second major phenomenon that's going on here is the relative lack of mixing of the jet streams from the northern and southern hemisphere. Interestingly, the jet streams, while their mixing is not unprecedented in planetary history, it is very, very uncommon, except within the last couple or 3 years. And now we start to see crossing over of the jet stream from the northern hemisphere, crossing the equator, going into the southern hemisphere, and vice versa. So we're starting to see that distinct difference between the northern and southern hemispheres break down with respect to atmospheric gas concentrations, and therefore with respect to various environmental phenomena. And I should point out that some of the truly amazing observations that have been made over the last several days. For example, it's all over social media today that Lake Michigan may get its first ever tropical cyclone tonight.
Yeah, I saw that.
I'm pretty sure that most of our listeners know that Michigan is not in the tropics.
Mm-hmm.
And so to get a tropical cyclone in Lake Michigan is pretty darn impressive.
Yeah.
Another little anecdote indicating how conservative my projections have been. There's a paper out just today called Even Worse Than Extinction. Russian scientist predicts bleak future for human race. Specifically, a Russian scientist by the name of Alexander Berezin, a renowned scientist from Russia's National University of Electronic Technology Research, is warning that if we continue on the path that we're going on, humans run the risk of eradicating not only the human species, but he claims all other forms of life not on Earth, in the universe.
Wow.
In the universe.
Wow.
So this is a huge claim, obviously, and you'll have to read the article yourself. It's just the article I've seen is at express.co.uk in Great Britain. But it's just another indicator of a couple of things. One, we are in unprecedented terrain here by any measure. And two, suddenly my projections regarding human extinction in the near term don't seem so bizarre after all.
I always thought you were right on, and I think that that the more near predictions are probably more accurate than the further off predictions. In the future, I think it's more near.
As I've indicated, I've tried to be relatively conservative in my approach, which is classic for scientists, especially academic scientists. But not everybody out there agrees with me and thinks that I'm taking the conservative approach. So
right.
I just like to point out when somebody like this Russian scientist comes out, looks even crazier than me, I like to bring attention to that sort of thing.
Right. So, it doesn't sound crazy to me. Okay, I've got a couple of questions here. Here's a question for Guy. It says, what does Guy think of Alan Savoy's holistic management of livestock for greening the deserts and combating climate disruption? Are you familiar with that?
Oh, yes.
It sounds like something
Savoy,
that we don't have time to implement. So, anyway.
Well, there's that, and it is not working.
Okay.
Alan Savoy is a snake oil salesman who came to the United States from Africa after his ideas failed to work there when implemented. His ideas have been completely dismantled by academic scientists in journal articles and books. In fact, among my first journal articles as a graduate student in the mid-1980s, took issue with some of his ideas. If you look at the kinds of things he's saying, they appear on the surface to make sense, but you don't have to dig very deep beneath the surface to realize that, for example, when livestock are out wandering around and using their hose to churn up the ground, they actually are not increasing water infiltration, rain infiltration into the soil. They're decreasing rain infiltration because they're compacting the soil. It might seem like they're churning the soil, so superficially, if you don't look too deep, that churning of the soil would seem to increase the roughness of the soil and therefore increase infiltration. But in fact, what happens is when you get a 1-ton animal out there walking around stomping on the ground, or say thousands of 1-ton animals, it compacts the soil. It might churn up a little bit of the surface, but an eighth or 16th or a half an inch down below the surface, the soil is heavily compacted, and so there's actually reduced infiltration. And you go through each one of Alan Savory's arguments, and they failed to hold up to scientific inquiry. This has been pointed out for more than 30 years, and yet he is very charismatic, and his message is appreciated by folks like TED, for example, so he has a TED Talk out there. But you look at the evidence through a skeptical lens, and it is not promising, to say the least.
Yeah, and a lot of people don't have that skeptical lens or discerning eye. They want hope. They want to find something that's going to make things work, and so they're looking through that lens. Okay, here's another question.
We all want that.
I know.
We all want a bright future that lasts for a long time. We all want that, including me.
Right.
So yes, we're prone to accepting the good news message. We're prone to eating the ice cream and never mind the information about diabetes.
Right.
And nobody would know about that better than me.
Really?
I'm an ice creamaholic.
Oh, okay. Okay, here's another question. Please ask Guy if he's familiar with the Thrive movement documentary and website, bringing issues like these to the forefront and organizing all people globally to a dramatic change to free energy technologies that, as I see it, could be the answer to lowering society's heat engine. So, what do you have to say about that?
Yeah. Well, there's no such thing as free energy that would actually violate the laws of thermodynamics. They're not called the strong suggestions of thermodynamics. They're called the laws of thermodynamics. And they indicate that there is no such thing as free energy. So the entire Thrive movement is built on free energy, which doesn't exist. So I put this into the same category as I put Mr. Savory, or as many people call him, Alan Unsavory.
Right. Yeah, I didn't even want to ask those, but those were some of the questions.
No, that's perfectly fine. I like that those questions come up, and they keep coming up. They are indicative of a society that is poorly educated when it comes to critical thinking skills. I'm reminded that in many countries in Western Europe, by the time a student graduates from high school, they're required to complete a course in media literacy or media criticism. And so this might explain why the United States, which has 4.5% of the world's human population, spends more than 50% of the global money on advertising. Americans are very easily manipulated by advertising, in part because nobody is ever required in their entire lives to take a media criticism course or a media literacy course. So they don't know when they're being presented factual information. They can't distinguish it from advertising. Why do you think we like beer and naked women and football so much?
Yeah.
Okay.
People
that might
can't
not have
discern.
been fair, especially the part about naked women.
Okay. I have one person wanting to know when the massive sublimation of gigatons of methane in the Arctic and subarctic regions are imminent. Like, will it happen this summer? Say June, July, August? I know you don't like to put actual dates on things because, it's hard to know, isn't it?
I'm stunned it hasn't happened yet.
Yeah.
The ice is very fragile in the Arctic right now. Thin, and it's fragile, and it resembles slush in many places more than it resembles solid ice. And that said, Tom Hartman published a book several years ago, I can't remember the year, called The Crash of 2016. And in it, he took what I thought was an incredibly conservative approach and predicted a financial crash far worse than 2008, 2009 to occur in 2016. But it didn't happen in 2016. It didn't happen in 2017. I'd be shocked if it didn't happen this year. But maybe, it's like there's this great Louis C.K. clip, and Louis C.K. is my favorite social critic, and occasionally he does stand-up comedy too. And he says, when it comes to your own death, the best you can do is, this is probably it. You can never say for sure, this is it. I'm dead now, because by the time you can say that, you're dead.
Right.
So the best you can say is, this is probably it.
Yeah.
And I think this year is the year Tom Hartman was 2 years ahead of schedule. I think this September is probably it. in terms of the collapse of the financial system. And that will, because of the absence of global dimming, that will create enormous heat that will release significant amounts of methane from the Arctic Ocean. Or maybe the methane, which is already coming out of the Arctic Ocean, will contribute to a virtual loss of Arctic ice and therefore cause that burst, whether or not we have financial catastrophe this summer. So, if it doesn't happen this year, then it's almost certain to happen next year, as projected by the U.S. by a paper in the Annual Review of Earth and Planetary Sciences from 2012, projecting an ice-free Arctic, or nearly ice-free Arctic, in 2016, plus or minus 3 years. So we're very, very close to that. I'd be stunned personally if we didn't have an ice-free Arctic and we didn't have a financial collapse in September. But I don't know. The best you can do is this is probably it. And that applies to the death of industrial civilization just as it applies to the death of individual human beings.
Right.
So, and I don't want it to happen, don't get me wrong. I'm no fan of the abrupt heating associated with the collapse of industrial civilization, even in the United States. And I'm no fan of an ice-free Arctic. But I'm just shocked, really, that we've managed to avoid both of those phenomena for as long as we have.
Right, right. Well, we had a latecomer join us. 661, would you like to ask a question of Dr. Guy McPherson? And thank you for joining us today.
Thank you. Not at the moment.
Not at the moment? Okay. Well, thank you for tuning in.
Somebody who prefers to listen instead of talk, I very much appreciate that.
Yeah, that's rare, isn't it?
It is. You almost never get that from me, do you?
Yeah. What do you say to people when they say we've got coming solar minimum and new ice age and all this stuff? How do you react to that?
There's no evidence to suggest any such thing. So, I keep seeing it. I keep seeing that the sun is the only controller of heating of the planet. I keep seeing that we're headed to the Maunder minimum that will lead to a new ice age, but I don't see any evidence presented to support those ideas. So I just, for the most part, keep ignoring them. They pop up on YouTube especially on a very regular basis. And increasingly, I just don't have time for that.
Right.
Because my life, like everybody else's, is short. And addressing trolls on the troll farm known as YouTube is just becoming too taxing for me.
Yeah, I agree. Do you have any thoughts on an upcoming pole shift? Do you cover that area or not?
Actually, if you look at my long essay, 32,000 words, called Climate Change Summary and Update at McPherson.com, you see, I think towards the bottom, that pole shift has already occurred. It's already underway. It has not been a 90-degree flip, but there has been a significant deviation in where the poles are now relative to where they were not very long ago, and that's attributable to abrupt climate change. So we're seeing it. How far it goes is anybody's guess.
Right.
I doubt if we, in our lifetimes, in the span of human from on the planet, I doubt if we see the complete flip. But it's one of those things that, sure, maybe, almost nothing would surprise me at this point.
Right.
Especially as an outcome of civilization and abrupt climate change and ongoing environmental phenomena. It's hard to surprise me anymore.
Right. I have one last question. I don't know if your expertise covers this or not. We did talk about some volcanoes earlier. Do you have any information about how likely a sudden slump of the Kilauea volcano flank into the sea is, and the Cascadia Fault in the Pacific Northwest?
Well, no, on the former. I've seen a lot of speculating about that.
Okay.
I'm not a volcanologist.
Okay, right. I didn't think you would
anything
go
close
into
to an
this.
expert on continental plate
Right.
shifting.
Right.
And, for both of those, I think it's I think it's very unlikely that we'll see a significant shift in the Cascades, significant enough to cause large-scale mortality of humans before abrupt climate change causes the loss of life of
Right.
humans in that area and throughout the globe.
Right.
But, it's one of those black swans that is stunningly difficult to predict. And you look at it in the rearview mirror and you go, well, somebody should have seen that coming.
Right.
But these things are in the category of so very speculative that it's almost it's like nuclear power plants. It's a zero infinity issue. There's effectively a 0% chance that something will cause a nuclear power plant to melt down. And when it does, the outcome is infinitely bad. So it's called a zero infinity problem. And we've seen that 0% play out now twice in recent history, Chernobyl and Fukushima, and we came very close to 3 Mile Island in 1979. So maybe the zero is being quite generous. In any event, I think the things that you're talking about here fall into the same sort of category of very unlikely to occur, but if they do, it's the kind of thing that, wow, we should have seen that coming, or wow, that's truly infinitely bad.
Right. Right. Well, you covered all of my questions that I had and questions of our callers, and I had a thought.
And I only said I don't know to about half of them. So that
No, you only said I don't know to about 2 or 3 of them. I thought you did really good, so I give you an A. So, people talk about, going to electric cars and renewable energy and stuff like that. And I have one word for why it'll never happen and why we will never switch over, and that one word is war, because this is a warring planet and they will never give up war, and all of the military industrial complex. And can't you just see them trying to do all that they're doing with little electric cars and things? It won't happen.
Well, yeah, I tend to agree with you, and I still think that there's such a thing as right action in the face of seemingly insurmountable odds.
Right.
And that we should pursue that right action, even though we can't be attached to the outcome or we'll go crazy.
Right. So thank you, Guy, for coming.
I'm a huge fan of trying to take actions.
Yeah.
And I also recognize that taking those actions can be personally expensive, and that the outcome is almost never what we desire.
Right.
So sorry to go on there.
That's okay. Do you have any last-minute words you want to leave people with?
Well, thank you for the opportunity again, Margo. I appreciate it. And I guess my final words for people are to, the same words I have used over and over again, that we are born into this, so there's no guilt, there's no shame, there's no blame. We can look around and everybody likes to do this. They like to point the finger. In addition, we can't predict the future with great accuracy, but we know that all individuals die and all humans go extinct. All species go extinct, including 6 species of the genus Homo that have gone extinct before ours. And so I would encourage people to live with urgency, to live with death in mind. And I don't think that's going to turn out badly if people are pursuing right action with urgency, regardless of how this turns out.
Right, and the more we know, the easier it is to prepare. And so with your message of, keeping people abreast of, the situation and how things are, it helps us have a clearer picture of what to expect too. So I appreciate you so much. So happy trails, and I hope you have safe travels back to Belize. Are you headed right back to Belize, or where are you going now?
Headed back there tomorrow night, basically Friday night. Well, I think the flight is actually at 1 o'clock in the morning Saturday, but close enough. In any event.
Yeah.
Thank you very much for the opportunity, Margo. It's always a pleasure to chat with you.
Oh, you're very welcome, and thank all the callers for calling in and joining us. And this show will be archived on my YouTube channel, and I have a BitChute channel, and then the audio podcast will be on my website. And my website is margoshealingcorner.com. And I will email you all those links, Guy, when I have everything up and done. And I look forward to speaking with you again sometime. And so, everyone, take care.
Sounds great.
Take care and love each other and go in peace. And until next time, just take care. Bye-bye.
Thank you, Margo. I greatly appreciate the conversation.
Thank you. You too. And everybody else, take care. Bye-bye. I hope everyone enjoyed our show today. I really did. I learned a lot, and I would like to thank Dr. Guy McPherson again for coming on to have this conversation and to teach us and help educate us, because we're all here just trying to understand what's going on. And if you'd like to find out more about Dr. McPherson, his website is guymcpherson.com. That's GUYMCPHERSON.com. And his blog is called Nature Bats Last. And he's posting on that all the time, and you can keep up with where he is in the world and where he's going to be talking, and archived interviews and things like that. Plus, he puts up great articles all the time. He also has a Facebook page, and you can just search on Facebook for Guy McPherson. And I'd like to also thank all the callers that called in, and also everyone who asked questions through the comments section on my YouTube videos, because that made the show. All those questions made the show, and I'd like to thank everyone for participating. And until next time, I hope everyone just loves each other, and I will keep doing weekly updates and finding interesting people to interview. And my name is Margo. I'm a hypnotist, holistic life coach, empathic spiritual healer. My website is margoshealingcorner.com, and my YouTube channel is Margo's Healing Corner. And until next time, everyone take care, go in peace, goodbye.